Assalamualaikum warahmatullahi wabarakatuh. We are Group 1 from CS 1124D. Today, for the subject MAT263, we will have a video presentation for our group assignment. The title of our case study is Application of Linear Algebra in Traffic Flow. Our group members consist of 5 people, such as Sharifah Nur Afika binti Said Hisan Sabri, Atirah Amani binti Arif Afendi, Amalia Farihah binti Rosli, Nur Diana binti Muhammad Zul Sharinan, and Nur Maisarah binti Salmi.
Hi, my name is Nur Diana. Before we begin discussing the issue and its resolution, allow me to briefly explain what linear algebra and traffic flow are. Linear algebra is a branch of mathematics that deals with the study of linear functions in vector space. When information related to linear function is represented in an organized form, and then it results in a matrix. Thus, linear algebra is concerned with vector space, vectors, linear function, the system of linear equation, and matrix. These concepts are a precondition for sister topics such as geometry and functional analysis.
Next is definition of traffic flow. Traffic flow is directed networks can be used to describe the street layout in downtown areas. The network's nodes are indicated by the intersection. The network's directed sides or branch are symbolized by the roadways. Along the branches traffic move, our presumption is that any vehicles approaching an intersection must also exit it. The flow into and out of each node are equal. We likewise assume that the amount of traffic entering and exiting the network is equivalent.
Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifah Nur Afika binti Said Hisan Sabri, and today I will be proceeding the presentation to understand and solve our first problem. The first problem states to consider the typical road network of Figure 1. It represents an area of downtown Jacksonville, Florida. The streets are all one-way, with the arrows indicating the direction of traffic flow. The flow of traffic in and out of network is measured in terms of vehicles per hour. Now, let us construct a mathematical model that can be used to analyze this network. In order to solve this problem, the first step in the application is to compute the flow in and flow out of the intersection into equations. Following traffic law, it applies that all traffic entering an intersection must leave the intersection. The conservation of flow constraints lead to a system of linear equations as shown below. The next step in solving this problem is including the method of Gauss-Jordan elimination to solve these system equations. The augmented matrix and reduced row echelon form of the system is as follows. After that, we need to express each leading variable in terms of the remaining variable. As expected, the system of equation has many solutions as many traffic flows are possible. Let us now use this mathematical model to develop more information about the traffic flow. All traffic flows must be non-negative, as a negative flow would be interpreted as traffic moving in the wrong direction on a one-way street. Thus, it forces any road work on Monroe Street should be allowed for traffic volume of X4 to be greater or equal to 0, and X4 must be smaller or equal to 475. Last but not least, suppose the part of street A and D corresponding to X4 is closed for repairs, then we would have the following solution.
So, here's the diagram of problem 2. For reference, it would be also useful to name intersection in this network, which is A, B, C, and D. Then, we label x1 until x5 for traffic flow that doesn't have variables. For these questions, we need to find the flow rate of cars on each segment of streets. Now, we will use these two observations to set up some equations. The first one is flow into the intersection must be equal to flow out the intersection. And the next one is total flow in must be equal to total flow out. Based on the observations, for the intersection A, it has only one street that brings car in, which is 85 cars per hour, and this must be equal to flow out of the intersection. We have two streets going out, which flows x1 and x2, and so the total flow out of the intersection is x1 plus x2. So, the equation is 85 is equal to x1 plus x2, and it same goes to intersection B, C, and D. After we obtain the equation, we need to rewrite the system so that all the variables are on one side and all the constants are on the other side. Then, we convert into the augmented matrix of the system. In order to solve our system, we need to perform row reduction for this matrix, and as the result, we can look the final answer on this slide. Here's the final answer based on row reduction we just performed before. To get the value of each variables, we need to read from last row. The last row is written as x5 is equal to 25. Then x4 is equal to 60. Meanwhile, x3 is free variable because it has no leading one. Okay, then x2 is equal to 10 plus x3, and the last one is x1 is equal to 75 minus x3.
Conclusion. Traffic flow is the study of interactions between vehicle, drivers, pedestrians, cyclists, other travelers, and infrastructure with the aim of understanding and developing of optimal road network with efficient movement of traffic and minimal traffic congestion problems. So we can conclude that linear algebra allows us to study traffic flow estimation using matrices and determine which variables have false values and which are free to be chosen. Thank you.